Friendo is MoNaCo,
Notes.
and we are in moles and stoichiometry. We're going to talk about some percent composition, and we're working page 17 in our pack. Percent composition is a tool that we use to figure out chemical formulas.
Yeah, that's where we'll go with this eventually, yes.
Yeah, it's what we use it for. It's also good to use for things like when we're doing how much water was in the hydrate.
Yeah, we could do a lab like that.
We are going to do a lab of that.
Good.
Or there's other activities like what percentage of your Smarties are green? What percentage of your Smarties are purple?
Right.
And can you figure out what percent of a stick of gum dissolved away when you chew it?
Ooh, don't give it away now.
I'm not giving it away because they got to figure out the procedure. So.
Okay, good. Real basics, guys. All percentages. If you see the word percent, it means, right? It means part over whole times 100.
Anything. It could be in math class, basketball, whatever.
Yep. Percent of boys in class. Percent of people wearing hats. Blah blah blah.
Part divided by the whole.
Right.
Times 100.
Right. So in our case, for chemistry, the whole is going to be the
gram formula mass.
There you go. And then the part is going to be the entire mass of the element in interest.
Right. The whole, I will say in chemistry, the whole could also be the total mass of a sample.
It could be.
And the part would be the part that got heated away or consumed or used up.
Okay, but in this case, percent by composition.
In these examples that we're going to show you, it's gram formula mass is the whole.
Correct.
And the part is each element within that compound.
Right, but the thing is, that's why I put total mass, because if there's 2 oxygen atoms, we won't use the 16 for the mass.
No, we'll use 32.
Because it's the total mass.
Yes, for sure. But when we use percent composition in our lab, we're going to use the mass of the sample we started with as our whole, and then the mass of the sample afterwards as our part kind of thing. So figure out what percentage of it changed.
Right.
So either way, it's always done the same way. That's the point.
There you go.
Don't let our semantics confuse you.
Right.
So to calculate percent composition in chemical formulas, you have to have a formula, first of all, to calculate the gram formula mass for, to figure out the whole.
There you go.
And so then we go into each element that was within that compound and treat it as a part to find out what percentage of the compound was that part.
Right. So we'll divide the total mass of that element by the gram formula mass, multiply it by 100. We have our percent composition of that particular constituent.
Right, so like if we have H2O, we'd have a percent of the compound that's H, and the other remaining percent of the compound would be O.
Yep. And it's honestly, a lot of times when you see the masses, it's real easy to figure out who's the bulk of the mass.
And that is the purpose of this calculation, to figure out what element contributes the majority of the mass to the compound.
Right. Well, let's do 2, and then we'll be done with this video.
Sure, you want to do the first one or the second one?
The second one looks bigger and badder, so I want that one.
Fine, simple ones. So, 2 steps. Sodium,
you got more room if
and
that means
the
anything.
problem would ask you, what is the percent composition of sodium in the compound sodium fluoride?
Right. For our practices and purposes, we're going to do
both.
Yeah, we're going to do them all. So that this way, no matter what the question asks you, you know how to do it.
So the first thing we got to do always is the GFM.
All right, so he's going to do it, calculate the gram formula mass.
So for NaF, I've got Na, I've got one of these. And for fluorine, I've also got one of these. I'm going to multiply by the atomic mass of sodium.
Na is 23.
And fluorine's 19.
You got it.
And so this gets me what my whole is going to be. So I got 23 plus 19, 33, 42. 42 grams per mole.
Beautiful.
Now, that is my base. Part 2, I got to find the, that's my base, my starting point. Got to have that. Part 2, I'm going to do the percent Na in the compound. And to do this, part divided by the whole times 100. So the part that was contributed to this mass for sodium was 23. So 23 divided by the whole, which was the total gram formula mass, 42 times 100. Gotcha. Got a calculator, Mr. Milks?
Do.
Why don't you plug that out while I set up the next one?
23 divided by 42 equals times a hundo. Hey, no. I got 55%.
So, about 55%, or exactly?
Well, it came out 54.76, so I'm going to round that up.
Yes, you could, but I want 1 decimal. So
all right, so
0.8.
I got around 76 up to 8.
And you got a percent in there, and we put NA underneath it.
Beautiful.
I want to be accurate here because when I'm done to check my work, my percents should add up to 100. If you had rounded to 55,
Well, I bet the next one would be
rounded to 46, but maybe it wouldn't. Maybe it'd come up to 99 or 101. I want to be a little more accurate.
Okay.
So that's fine. And when you're doing these calculations in class, we'll probably just tell you full percentages, maybe one decimal place at most.
Yeah.
So if I want to do the percent fluorine now, I have to take the part divided by the whole. The part in this case now for fluorine is not 23, but it's 19, because that's the gram formula mass for fluorine. 19 divided by 42 times 100. What do we get here on the calculator, Mr. Mann?
Oh, yeah, I'm falling
19,
behind.
40 seconds.
45.2.
45.2% fluorine.
Beautiful.
And that actually adds up perfectly to 100%. So Mr. Nose, take it away on the second one.
It does. All right. So we're going to have to calculate our gram formula mass is our step 1 again. Step 1, calculate my gram formula mass. I see that I have calcium, I have nitrogen, and I have oxygen present. I like to do the mass first, right? So I like to do the mass of calcium. It's 40. And I have one of them present, so that's 40. And then I have to distribute the two, remember, one of the skills we learned earlier. So now I have two nitrogens. I got a mass of 14 times 2 is 28. And oxygen is 16. And 2 times 3 is 6. So that is, I believe, 96. I got to add these bad boys up so I can get my total. I got 164 grams per mole.
Yeah.
As a GFM for this bad boy.
So now you got to do your percents. And you got 3% to do.
I'm good with it. I'm good with it.
You said you wanted
I'm
to.
going to do it format-wise the way Mr. MoNaCo did it in my class today, 'cause I like the way he did it in class. I thought it was kind of cool. And one thing I just want to throw out there, if we do it this way, our total masses for nitrogen now is 28, and our total mass for oxygen is 96 in the element. That's going to help me here when I plug them in because it's already calculated for me. I'll have to go back and redo those numbers. So let me do calcium first. Percent calcium is going to be my part over whole times 100. And I see my part is 40. My whole is 164.
24.4%.
24.4% calcium.
Yeah. Put a box around it. Equal sign. Yeah.
Here we go.
Thank
Yeah,
goodness.
Yeah, ooh, please.
Don't upset the chemist.
Yeah, my goodness. And then percent nitrogen is going to be, my part now for nitrogen isn't 14, it's 28 because I got two of them.
Right.
So that's one of the keys I wanted to, try to hip us to. Divided by my whole, which is still 164. I'm not recalculating that. I got it.
I got a 17.07, so 17.1.
17.1% nitrogen.
Nice.
Okay.
Now, if you wanted to play the flop game here and subtract those from 100, I don't want you to. So you got to do all of them.
Yeah,
You might think you can get crafty and do that, but
you just don't want to get burned and be off by one number. Okay, so I got 96, which is my
58.5.
58.5% oxygen.
Bam.
And I see my 5, my 4, my 1 add up to 10.
Boom.
And then 15 and 5 is 0, so we're good.
Yeah,
That's
gets
up to
100.
exactly 100. Perfect.
And the cool extension, the application question on this would be like, which element contributes the most mass, percentage by mass, to the compound calcium nitrate?
There you go.
You might think calcium would because it's 40.
Because it's the heaviest element.
Right, but when you do the math like this, you realize since there's 6 oxygens,
That trumps.
yeah, 6 times 16 is 96. That's more than double the mass of the compound from just the oxygen. So, fun fact, most of the mass of the Earth's crust is due to oxygen.
Yeah. And what's nice though is on the test, that Big Bad Regions test, a lot of these questions, if they're like small part 1 guys, they ask you what is the percent of just oxygen,
in the compound.
and then they give you the gram formula mass even.
Right, so you just do the part divided by the whole and you're done.
Yep.
And you don't have to do it for every element.
You
So.
just would have to do the part for oxygen.
Cool.
You're moving on.
So let's see what else we got here for us today. That's it.
We're done.
2 videos, 1 day. Got a bunch left to do. This unit's flying.
Yeah, you guys are doing a great job in class, by the way.
Yeah, doing a great job. Now I'm doing a great job outside of class too, and watch your homework.
I think that, rubber meets the road. When we come back from Christmas,
Hopefully.
are you still going to be able to calculate gram formula mass and get through a lot of these
Great thing
easy
about
tasks?
the internet is you could go do it over and over and over again.
That's right.
That's why we put this on YouTube for you.
There you go.
You're welcome. Count atoms, apply mass, calculate percent.
There you go.
Thanks for watching.
See you guys.